My name is Selinyo Didos Dedit. I'm here to present my database management systems project. And my project is about the livestock farming management systems project. The database systems I chose include MySQL, PostgreSQL, MongoDB SQLite, Microsoft SQL Site, Firebase, Firebase real-time database, among others. The database system that I chose was MySQL, and reasons for the choice are: MySQL is user-friendly, making it easier to set up and manage. MySQL can help minimize costs, which is particularly important to small and medium-sized livestock farms. MySQL has a strong community support. MySQL performs well with read-heavy operations. MySQL provides data security features. MySQL integration capabilities with various applications and programming languages. MySQL is flexible. MySQL provides robust user management features, among others. Then I go to part two, where application domain was the livestock farming management system is designed to streamline and enhance management of livestock farms. It will automatically support various research tasks related to livestock care and farm operations. Key tasks and operations supported include health monitoring tasks. Health monitoring, the key tasks supported by my database include health monitoring, breeding, feeding management, financial management, and the user groups served include farm managers, veterinarians, farm workers, accountants, among others. Then benefits of my database. The tangible benefits include increased productivity, lower veterinary costs, streamlined record keeping. Then the intangible benefits include enhanced decisions making, improved animal welfare, stronger communication, which improves collaboration. Then the costs related to my database. The tangible costs include software development costs, hardware costs, training costs. The intangible costs include change management, ongoing maintenance, animal welfare concerns, risk of disease outbreak, among others. Then the skills adopted from my database include users will have varying levels of comfort with technology. Training material should include hands-on tutorials, use of manuals and facts to the underlying adaptation effort. Resistance to change is common. To counter this involves users in the development process to gather their input and ensure the system meets their needs, provide ongoing support and encouragement to build confidence in using the new system. Then the risks associated in my database include technical risks, operational risks, data security risks, organizational risks. Then limitations: database accuracy. The system relies on accurate input of data, e.g. this one, the e.g. health information, feeding schedules. Errors in entity could affect the decisions. Then resource limitations: the system may not scale well in farm if the farm grows significantly in size. Then I go to my database design. That my database design, I had the entities and attributes. The entities include livestock, health records, breeding, feed, employee. Then each entity has its own attributes. Livestock has entities like animal ID, which is a primary key, breed, age, weight, and date of birth. Health records has attributes like record ID, which is the primary key, treatment type, date administered, notes. Breeding entity has attributes like breeding ID, which the breeding ID, which is the primary key, sire ID, breeding date, and offspring ID. Feeding entity has attributes like feed, ID, which is the primary key, animal ID, which is the foreign key, feed type, quality date, feeding, quality date. Employee as an entity has attributes like employee ID, which is the primary key, first name, second, last name, and date of birth. Then I go to relationships between the entities and the entities. Livestock has a relationship with one and health record at entity. These are the entity relationships. Livestock and health. Livestock provides data to health records. Livestock and breeding entities. The relation between the livestock and breeding. The livestock provide the livestock give offsprings to breeding. That's the relationship. Then the relation between livestock and feed. Livestock eat feed. Livestock and employee. The relation between livestock and employee is that employee takes care of livestock. This is the interrelationship diagram. This is my diagram. It shows the relationship between the it shows the relationships between the entities. That's the diagram. Then I go to user interface. This is the sign up form. I did it from Visual Studio and give the output here. Then I go to my database to description of queries and reports. First, this is creating tables. I I did it from WAMP server. I went to MySQL, create database livestock farming management system, entered OK. That's how I created that database. This is how I create the tables. You go to MySQL, create table, enter the entities, the variable type, enter the primary key, the everything. I created table feed, created the table health records, created the table employee, created the table breeding, create a primary key. When creating a table, it's every table has a primary key which is different from the other. Feed, for example, feed has a primary key as feed ID. Enter int primary key, auto increment, not null. That's how I created the primary key. I go to describing table. To describe tables, I describe tables. The tables appear in a table form. You enter describe health record, then they bring it for you the table. These are the various tables I described. Then inserting values in the table. That's how I inserted the values in the table. Then conclusion of my database project. The development of livestock farming management system has been a comprehensive and enlightening journey. The project aimed to design and implement a robust, efficient, and user-friendly systems for managing livestock farming operations through rigorous research, analysis, and implementation. We have successfully created a system that streamlines farm management, enhances productivity, and improves decisions making. Thank you.